Hi everyone, I'm a programmer working at a tech company and welcome back to my channel Bit by Bit. Here we break down complex coding concepts into simple and one bit at a time. So yeah, this is a problem lead code 22 generate parenthesis. Okay, so here I want to add one thing. In the last video also we solved the problem generate parenthesis, but the difference between the last problem and this problem is that in the last video we have generated all the parentheses that can be possible uh, f- by all the permutations, and in problem we are going to solve generate all the valid parentheses. Okay, so I want to add it here. Okay, so yeah, so now the question still remains the same. Given n pair of parentheses, generate all the possible combination of parentheses that are well formed. So yeah, this condition is added now. So let's see what things will change. Yeah. So if we discuss about the last problem, okay. So this is the thing we have discussed, or you can go back to the video, or if you haven't watched it, you can watch it, or I will give the gist of it. So the idea for solving that problem was that we uh, we have the problem for generating all the parentheses for the 2n. So if we are given n, then we have 2n pairs of the parentheses, and is uh, so in the last problem what can happen? One, there can be one opening bracket and the rest of the closing bracket. There can be possibility that there can be two opening bracket, rest of all is the closing bracket. Uh, okay, so like this in the last problem this can happen. Okay, so yeah, we have n pair of parentheses, so total 2n parentheses, and what we said that we will generate for the last spot and we will figure out the rest of the answer by recursion. Okay, in the last video we have discussed this. Okay, so we have written the base case also, our we have written algorithm also, like we have written the function for generate parentheses. So algorithm was like take input of n. We need a container to store our answer. After that, we have function generate parentheses where we have written the base condition where we will store our answer. S is the temporary answer which was getting formed that time. Okay, so what we have done in the main function, we have called a generate parentheses function with the empty string and with the n. We have added the opening bracket first. Then we have called the generate parenthesis with the current s, and we have popped back this last character, and we have added the closing bracket. After that, we have called generate parenthesis again. So what happened? It will generate all parenthesis combination. Okay, it will generate all the parentheses that uh, all the combination of parentheses. It can be valid, it cannot, it can be invalid. Okay, it will generate all. Okay, so now we need to see. So this is a like a part of revision kind of thing. This is a in the last video we have covered till this. Okay, so now we need to think what we need to add here. Okay, what we need to add here so that this solution can be used to solve this generate all valid parentheses question. Okay, so we have like at least we got to just that we need to solve this problem, okay, using the concept we have like discussed earlier. Okay, so yeah, let's see what we can do here. We can we have a base condition. Okay, yeah, okay. So yeah, there are of course two ways. One is a brute force way, one is optimal approach. So yeah, let's go with the solution which like which everyone can think of right now. Okay, so yeah, so if we see this section of code, okay, so we had a base condition. Okay, so what was the base condition? Okay, so what we are doing, we are generating all the combination. Okay, and now we need to generate valid set of parentheses. Okay, valid set or valid sequence of parentheses. Earlier, what we have, earlier what we have was that we had all the sequence of parentheses. Okay, so this valid sequence of parentheses and the all sequence of parentheses. Okay, can we say that, yeah, this valid sequence of parentheses, okay, is subset of all the sequence of parentheses. So if this is something, okay, if it is something that let's say all sequence, then the valid sequence will fall under it. Uh, it's just intentional, it can be derived from the solution also. Let's say we can take an example here. Okay, we have n equal to 1. Okay, if we think of what we have, okay, we have n equal to 1. So if we go for the all sequence, okay, all sequence, then what we have, okay, first what we will do, we will add opening brackets, then opening bracket, one set is this. Okay, opening bracket, closing bracket, one set is this, closing, closing, closing. Okay, these are the four possible combination that we have. If we talk about valid sequence, if you see, the valid combination is this only. So we can see valid sequence is a subset of all sequence. Okay, so one thing which I forgot, I wanted to tell you what is valid sequence. Okay, yeah, so valid sequence, okay, where I want to write some case conditions. First condition is that opening bracket, mm, uh, 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 equal to closing bracket. I'm talking about counting here. Okay, so if we have n pair, okay, if we have n pairs of parentheses, so and like the counting of opening bracket should be n, the counting of closing bracket should be n. Okay, n closing bracket and n opening bracket. Okay, yeah, and the second one, opening and closing bracket, opening bracket and closing bracket should be balanced. What it means? It means that if we have opening, we can, if we have, let's say we have opening bracket left, okay, then after that, only one closing bracket can be done. It cannot be like that. There are two closing bracket at afterward and before we have one opening bracket only. So this is a like not balanced. What else cases can be not balanced? This is like, this is not balanced. Counting is same, but they are not balanced. Like we have an two opening bracket, two closing bracket, but it is not balanced. Okay, so this is the like a and this is like definition of valid sequence, and we got to know that yeah, valid sequence of parentheses will always be a subset of sequence of all parentheses. Okay, that this thing we figured this out. So let's relate this problem to this the earlier the problem we have solved. Okay, so what changes we need here? Okay, so if we see this base condition, okay, we know that if we reach here, we will get the both of the answer. We will get the valid sequence also, invalid sequence also. So if we filter out invalid sequence here, then our answer will store valid sequence only. Okay. So yeah. So yeah, if we will do that, then we will get our answer. Okay. So let's zoom this out and I will write the code for like how we gonna check out how we gonna filter out this invalid sequence and the valid sequence. Okay. Yeah. So in here only in the base case, just before this line. Okay. Let's first make that function. Okay. We will talk about that function. Here we will write some function. Okay, what it does, it will check whether the sequence which is generated was S. Okay, S is the current sequence which we are having. Okay, it will check whether this sequence is valid or not. Okay, okay. So we can, yeah, okay, I cannot do it in this. Yeah, yeah, yeah. So we want to check whether the sequence is a valid or not. Okay, so there are two output for this, two return output for this function. So it will be a bool. Okay, we want to know true or false. Bool is valid. What we have here, we have a string. Do we know the size? Yeah, we know the size. It is n or 2 into n. Size is 2n, but we will pass n. Okay, just for uniformity. And yeah, so how we have written down the cases. Okay, we have written down the cases. Sorry, we have written down the condition. So what we will check this condition on that string. If opening bracket and closing bracket counting is same, it then we will check if the opening bracket and closing bracket should be balanced or is balanced or not. If both condition are followed, then we will say yeah, it is a valid sequence. Store it, otherwise don't store it. Okay. So for the first condition, what we will do? We will go string s int n. Okay. We will go through s. Okay. What we will check? We will check if okay, if x is opening bracket, else. There can only be two cases, like if like this character is a opening bracket or this character is a closing bracket. Okay. So if this is a like opening bracket, what we will do, uh, we will increase the counting of uh, opening bracket. Okay, we can count now. We need to check if like number of opening bracket is also one, we and number of closing bracket is also n. Okay, so we will have int o equal to 0, c equal to 0, which or if you have o, you can reduce closing bracket c. That's all on you, how you want to do it. So if x equal to opening bracket, okay, we will increase our O to the count of opening bracket, okay. And if we have else, we will let me reach this. So yeah, if x is equal to opening bracket, then we will increase O, else we will increase C. In the end, we will check if opening is not equal to C, whatever the region, okay, we will return false. Else we will check, else we will check, we need to have some flag which will check second condition, like either we are having balanced parenthesis or not, okay. So uh, this is like one way of doing things, okay. Yeah. Or what you can do, okay, when you are saying that, yeah, I have encountered opening bracket, I will increase my count, okay. Just have one variable, okay. This will tell, okay, if your number of opening bracket and closing bracket are same or not, okay. So what we will do, when we reach opening bracket, then we will increase the count. When we reach closing bracket, then we are closing down to 0. So we will like reduce that count only. Okay. So yeah, you can do this. Okay. And if in the end, if your O equal to J, O is not equal to J, then it falls. Otherwise, you will return, you will check that condition where it is balanced or not. Okay. You will, you need to have some function like check also that this is a balanced or not. Okay. And after that, you are going to return your answer on the basis of that. Okay. So if we call that function here, okay, we let's say we have some function where we check whether like this string is balanced parenthesis or not. Okay. So it will again take order of n time in order of n function. Okay. So we don't want to do that. What we want to do that is somehow we want to incorporate that function within this function only. Okay. Somehow we are traversing the string. Somehow we want to figure out a way, okay, such that we can check at any point whether this string which we have generated till now, it is balanced or not. It is like it is okay or not. If at the some point it is not balanced, okay, then of course on the further point it won't be valid. I will show you some case. Okay. Let's say uh, yeah, let's say we have n equal to 2. Okay. Mhm. Okay, sorry. My pen is not working somehow. Okay. Yeah. So what where we were? Yeah. we were talking about, we need to somehow incorporate that functionality into this function only. So while we are traversing, okay, while we are traversing, okay, at that time only we can figure out that yeah, this is balanced or not. Okay. So what we can do it for that, if let's say we have encountered opening bracket, okay, and we will increase the count of opening bracket. Otherwise, we will decrease the count of that to overall balance. Okay. So like if we have encountered opening bracket, we will increase O2 plus one or one. If we encountered closing bracket, we will decrease it. Okay. Okay. Now what we will say, okay, we don't need to check, don't need to have another function. While traversing, okay, at any point, at any point, if at any point, if the number of closing bracket, okay, are more than the number of opening bracket, we all know that we are checking for that opening bracket and closing bracket, the counting should be same. Means you have an opening bracket, you have an closing bracket. Okay. If at any point of a string, okay, the number of closing bracket is more than the number of opening bracket. Okay. Then what we will say? We will say that this parenthesis is invalid. And if a sequence is invalid at any point, then we are sure that it cannot be valid after any point. Okay. If we have n number of open parentheses, n number of closed parentheses, then if the sequence is invalid at any point, then it cannot be valid after that point. Okay. So we are coming out with this logic, and what we will check if here only, yeah, okay, and so many signs. So here only in this loop, if if anywhere this O is becoming zero, sorry, is getting negative, then what we will say here the number of closing bracket is more than the number of opening bracket. Okay. Then if a number of opening bracket is more than a number of closing bracket, we will say this sequence is invalid at this point only. Then how it will be valid after that? Okay. So we will return false from here only. And after that, we only have one condition that the opening bracket and closing bracket should be zero, equal. Then we will check why with this condition if this overall balance is overall like addition of closing bracket after like subtraction of closing bracket is zero, then we will say yeah, number of opening bracket and closing bracket is same. Then we will return true, and we do not need to have then else condition here. Okay. So yeah, this is a function, okay, that we need on top of it. We will add this function here only. I will add, I will add it here only. Okay. So we will check if it's valid of we have s comma n. Okay. If this string and n is valid, then only we need to push back this answer, and otherwise we don't need to push back the answer. Okay. Otherwise we'll so yeah, this is the only solution. This is the only application we need. Okay. So mm, I don't know why it did not working, but yeah, I will fix this later. Yes. If we talk about time complexity here, okay, time complexity is again order of 2n. Like we have number of parentheses 2n. Okay. So yeah, again we are doing recursion. We are going through all the generated like we are filtering out the answer, but still we are going to every case, like, and we are saying, are you valid? Are you valid? So it means we are checking every case. Okay. So time complexity will be same. It will be order of, like, we are having two possibility at every two n place. So yeah, it's kind of order of two n, and yeah, again we are checking, we are going through this function also. So yeah, it is like order of 2n and 2n for, okay, mm, like, yeah, for this space complexity, there is like order of n space we are using, okay, which is like recursion stack, again, the stack which is like developed in background. So let's talk about this and more. What is happening? Okay. For all the cases, what we are doing, you are going through the n is a size of string. Okay. So we are sure that every sequence, if we reach there, every string will have a size of 2n. Okay. And what we are doing, we are iterating it through once. Okay. So yeah, that's, and we are doing it for all the all the sequence. Okay. So for all the sequence, we are having order of n time for this function. Okay. So that's why we have multiplied it here. Yeah. So yeah, this is a space complete and this is a, okay. So this is a like little brute force. It is a brute force solution of this problem. Okay. Mm, uh, let's talk about the optimal approach. Okay. Okay. So let's say if you are thinking to optimize this, okay, what we can avoid? We can avoid that for, even if the sequence is invalid, we are running this function. Okay. This is which is taking order of n time. Okay. So we want to avoid this only. Okay. Because if the sequence is invalid, why we are like going through this function, why we are having extra time to like do this? We want to avoid this. Okay. So how we will avoid this? Okay. Um, okay. So here, what we have to, like, what was the intuition? Intuition was that we are generating all the parentheses, all the sequence of parentheses. Okay. And when we are reaching out to the answer, okay, then if it is valid, then proceed to the answer. If it is not valid, reject it. But how about if we reach this base case, then only we have a perfect answer. Then only we have valid answer. Then we do not need to run this function. Okay. Let's say if I'm reaching this base case, if I'm reaching the at the end of the recursion with the perfect answer, with my valid answer, then we don't need this function all itself. Okay. Okay. So for that, we will modify this a little bit. The function would be same, only the some parameter, some thing will change. We will see how it will change. Okay. 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 Yeah. So let's say while generating, while going through the recursion, okay, while generating the parentheses, like the sequence of parentheses, like what we are doing, we are adding the opening bracket, then we are calling generate parentheses, then we are popping it out, then we are adding the closing bracket. Okay, that's how like we are doing. Okay, uh, so if we want to avoid this is valid concept. Okay, and if we reach this answer, then only we have the valid set only. Okay, okay. So Okay, so what we can do, okay, what we can do, let's remove this function. Okay, this is what we want to achieve, but we need to do some modification. What modification we need to do? Okay, we can have a count of like what is the problem for it? What we are doing in this function? We are counting the opening bracket and closing bracket, and at any point we are checking that it should not be less than zero. It means closing bracket should not be greater than the opening bracket. Okay. If we check this condition in the middle somehow, okay. So for checking that, now from here you can get the intuition. Like you need the count of opening bracket and closing bracket in the recursion itself. At any function, at any step, you will need that count. Then only you can check. Okay. So let's say I'm passing 0, 0, which is a count of opening bracket and closing bracket, and I will have it as input here. Okay. So when we are adding opening bracket, okay, I will increase the opening count by 1. When we are like adding the closing bracket, I will increase the closing bracket by 1. Okay. Even we will move this step also here only. Yeah. We can move this step here only. Yes. Why here? We can remove this block back. Okay. So yeah, when we are adding the opening bracket, we are increasing the count of opening bracket. Uh, when we are adding the closing bracket, we are increasing the count of closing bracket. Okay. So, and when we reach there, we want to have a valid answer. Okay. What checks we need? Okay. So we all know we have for the well-formed parentheses, we have a like number of opening bracket and closing bracket should be same. Okay. So if we have n pair, then only we will have n set of opening bracket. Okay. So here I got one condition. If you will add opening bracket only, the condition is if opening bracket is less than n. Okay. If opening bracket is less than n, means you have still more open bracket to put it in the sequence, then only you will add it. Okay. So this makes sure that, yeah, we won't have more than an opening bracket. It means we won't have more than an closing bracket also. Okay. But still there is a like one check needed. What check needed? We do not need, we want, we don't want to have this O less than zero. What it means? Means we do not want to have number of closing bracket should not be greater than number of opening bracket. Okay, because this will then it will lead to like invalid sequence. Okay, that we have reduced here. We have discussed that. Okay, here only. But yeah. So for that, so yeah, what is the condition? We do not want. What is the condition? Condition is that number of closing bracket should not be greater than the number of opening bracket. Okay, so here only we can have if closing bracket is less than number of closing bracket is less than the number of opening bracket, then only you do this step. Okay, yeah, then only you do this step. Otherwise, it will lead to an invalid sequence. Now we have applied both check. Number of opening bracket should be less than n. It means number of opening bracket max reach to n. And here we have like do the check that if number of closing bracket is less than the number of this both condition will lead to the valid sequence only here. Now we have avoided this function. Okay, so we have now we will, yeah, this is a solution. Now we will talk about time complexity. Okay. So how we have reduced this time complexity? Okay. First of all, we are not having, okay, this time. Okay, because we are not calling this function this time. Okay. Yeah, you can say this is a time complexity. If you want to deep dive more into it, okay, so exact time complexity, because you are having this condition also. Okay, so some of the like nodes will be lost from the recursion tree. Okay, no, yeah, this answer is fine. Nobody will ask about that. Okay, but still, like there is a Catlin number. Okay, so Catlin number, what is it is said to be C of n. So actually, the like time complexity will be order of that only. Okay. Uh, if you want to understand more into it, I will tell you by example only. Okay? Let's say if you have four, okay, uh, we will take some easy example. Okay, we will have two. Okay, so we are in this solution. We are having only valid sequences at the end at the base condition. Okay, okay, and for n equal to two, we have one valid sequence. Okay, so let's count the TC in the step. Okay, so there is a one step function. This is a like one step function. This function, okay, will traverse once. Okay, will do only one step in case of n equal to two. Okay, and this function, okay, the number of valid sequence. Okay, it will do 2 to 2 to the power 2n. Okay, so yeah. 2 to the power 2n means 2 to the power 4. It means 16 step. Okay, something like this. We're only uh, n equal to, if you go, let's do the Catlin number. Okay, the time complexity here. Okay, so Catlin number is actually 2n factorial and factorial into n plus 1 factorial. Okay, okay, so it's kind of 4 factorial, 2 factorial, into 3 factorial. Wow. It will lead to your answer. Of the answer 12 by 6. Yeah, two steps. Okay, so if you see this, okay, so this is example. If you want to see this, okay, then what happened here? We have two spots. Okay, we have two spots. Okay, it's n equal to, so we have four spot. Okay, in this here, we have two options here. 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 We are multiplying it. We are getting the 16 step. Okay, this is easy. Let's understand this. Okay, so in the 2n, okay, this is actually a formula. This formula is from the permutations. Okay, PNC. Let's say if you have, so what happens? Okay, in the permutations. Yeah, it is formula. Yeah, so it is formula, but of course I cannot explain the derivation of formula. What I will explain that in this we have 2n. It means n equal to 2. We have 4 total bracket. Okay, so this 2n factorial, this 4 factorial. Okay, this 4 factorial is representing the permutation of that 4. bracket. Okay, and again from this n factorial into n plus 1 factorial. Okay, so n is like 2, we have opening bracket, and 2 we have closing bracket. Okay, so this n factorial and n plus 1 factorial means 2 factorial and 3 factorial representing the conversion of closing bracket. Okay, so now how you want to fill it? Okay, we need to see. Let's say if there are four permutation. Okay, then if nothing is pushed, nothing is placed out there, then we have four total factorial. Okay, four factorial for all the permutation, all the four bracket that can be pushed here. It will be subset of one of the four factorial. Okay, then we have done the 2n factorial. Okay, now let's say you want to place two opening bracket and two closing bracket. Okay, let's say if you want to place two opening bracket and two closing bracket for this varied sequence. Okay, let's say I have pushed two opening bracket. Okay, so now how many places we have? One, two, and this also. Before that also, this is also valid permutation. Let's say if I put one bracket here and if I put a one bracket here, then this is a like valid step. So after placing this two opening bracket, we have three places to put. Like if we have pushed two opening bracket, then we have three places to put the closing bracket. Okay, then that's why if like we are dividing it by a 3 factorial, we have two opening bracket, two closing bracket, but we are doing 2 factorial, 3 factorial. We are dividing, we are reducing the number of the total overall factorial. Okay, overall the permutation by, we are reducing the number. How we are doing? First, we have like put down the 2 factorial, put down the 2 bracket. Okay, then we have divided it by 2 factorial because these two are not part of only one. Okay, so they won't rearrange in between. Okay, so that's why we have divided it by 2 factorial or n factorial. But after putting down the two opening bracket, we have three spots for the closing bracket. Okay, so that's why we are dividing it for from the 3 factorial, not the 2 factorial only. Okay, so yeah, this is the like this is called Cardinal number. Like this is a famous problem in the PNC. Okay, yeah, no, no more discussion needed for this topic. You can read it. Uh, like also you can say like this is a sigma of CI into Cn minus I. Okay, and this is also a one. This will also like sigma. Sigma sign and Ci Cn minus 1 will lead to the same answer. The Catalan number. So yeah, it have a history, you can read it on. And the space complexity, yeah, for the space complexity, what will the answer? The answer would be like a same order of Cn, or basically you can say the order of n, which is like recursion stack. Okay, like depth of so yeah, this is all we have gone through. We have solve this problem out. I need to we have are we left with anything? I don't think so. Yeah. So I will stop this video. Yeah. If you like this video, like, share, and subscribe. Thank you.